Hi, welcome to the BetterBricks Interpreting Electric Meter Data training series. Or, it's 10 p.m., do you know what your power is doing? This training is broken down into 5 parts. This is part 4 about interval data. What do you do with it once you get it? In this session, we'll discuss software tools, sample load shapes, and documentation. Once you have your interval data, you can search for a software tool to use it with, unless you're very proficient in Excel and trying to plot the data yourself. You can go to the BetterBrickscom website and search for software tools. This is an example of one of the screenshots from that page. They show some of the software capabilities of the tools that are available from the utilities, some public software tools, and also commercially available software tools. Please check their website for updates. Some things you need to think about when you're comparing the software. Are you able to track utility bills in there? Are there benchmarking tools? Are there things that will allow you to do trend logging? Can you put multiple utility types in there? For example, gas, electricity, water, possibly other things like garbage. Can you collect data from other sources across multiple utilities? Can the data be exported? For example, exported into Excel where you can do other things with that data once you have it. Unless, of course, the software itself has lots of different charting options that allow you to do what you need to do to be able to evaluate your data. So the next few slides we're going to be discussing the different types of charting options for the data that you get. Back in session 2, what is your energy bill all about? We talked about a load profile. In this case here, this is a number of different days, actually a whole month of energy usage, with a different line for each day. The first thing we notice about this pattern is that there's a difference between the weekdays and the weekends. On the weekdays, you can see that energy usage starts up anywhere between 5 o'clock and almost 7 o'clock in the morning. On the weekends, energy usage doesn't start up until 7 o'clock and makes some steps around 9 o'clock and 11 o'clock till it gets to its highest usage around noon. Where on the weekdays, you can see the energy use again starts at between 5 and 7 o'clock and it ramps up continuously with everything being running between 9 and 10 o'clock in the morning. In the afternoons, there are some different days that the energy usage is different, quite a bit different. In this case here, this happens to be a facility that the cleaning crew comes in the evenings around 6 o'clock and cleans till around 9 o'clock at night. In this case here, on weekdays, energy usage drops off typically after 5 o'clock. The cleaning crew comes in from 6 o'clock until 9 o'clock, and so the energy usage stays up during that period of time. There are a few days, in this case on Fridays, that the energy use drops off at 6 o'clock. In this case, the cleaning crew doesn't come in on Fridays, they come in over the weekend and clean. So the energy usage was able to be shut off a lot sooner. After about 10 o'clock at night, the energy usage stays at the same base level until things start up again 5 o'clock the next morning during weekdays. The big thing here is to not notice what each individual day is doing, but to get an idea of what's happening with the patterns. This shows you when things are starting up and when things are shutting down, and it's up to you to find out what those things are and finding out if that's normal for your facility. In this case here, this is a single point trend, which is just looking at one day at a time. In this case, this facility starts up at 2 o'clock in the morning. Now 2 o'clock in the morning may seem like an odd time for the whole building to start up, so that's the first thing that I would look at on this building and say, should things be starting up at 2 o'clock in the morning? Maybe you have a shift coming in. But if this is an office building, I wouldn't expect to see it start up at 2 o'clock in the morning. The other thing that happens here is after 11 o'clock in the morning, there's this large cycling load here. In this case, this is a chiller that's malfunctioning and having some problems by cycling up and down. Not only is this probably not maintaining the building as comfortable as it should be, but also potentially providing additional wear and tear on the equipment. This is another single point trend. In this case, it's looking at a span of 31 days. Now the interesting thing about this is you can see different things that are happening. For example, these two lines down here at the bottom are showing you that there are a few days here that things didn't get shut off all the way at night, as they typically do other days. And that's a difference of about 80 or so kW of extra things running all night long. These kind of changes are going to be ones that affect your energy bill. Another thing to look for in a software is the ability to overlay different types of data. Now these could be from multiple meters. You could show 2 electric meters on here, or maybe overlay a gas meter with an electric meter, or possibly even weather data. In this example, the yellow lines here is the temperature in degrees on the right hand side of the graph, and the blue lines are your demand readings. And you can see how as the temperature goes up, you get to a certain point and the energy use goes higher on each day. As energy use goes down, this building is shut down in the evening. The temperature goes back up, but not as high. As you notice, this was only going up to about 65 degrees, where you're up at 80 degrees here, and so your peaks for those days aren't nearly as high. Now in this instance, this is a week, so this is your Monday, Tuesday, Wednesday, Thursday, Friday, and your Saturday and Sunday usage is a lot lower. This is typical of an office building that's used mainly Monday through Friday, with the weekend being at its lowest value when things are shut off. In this case here, the energy usage dropped from about 600 kW down to 150 kW for approximately an hour. A lot of times you may see that because some facilities have a backup generator they may run and they may be testing it. That usually is done on Sundays. Another thing you can do instead of overlaying with weather data is to overlay different dates. In this example, this is an office building with 1 week laid over the top of the previous week. You can compare the energy usage and see how those different weeks vary. The baseline for this building, it doesn't go below 600 kW. So I would look at this in this first Monday and assume that on this day here, this building was shut down on that Monday. So it's probably a holiday.